So let's look at calculating a confidence interval for the data that we looked at earlier in this chapter. So again, this is the example problem 4-3 from the end of the chapter. So we have these 8 values. We calculate the mean and the standard deviation using Excel. And the question is, what is the 95% confidence interval for these measurements? So we'll calculate that real quick and then also talk about what does that mean exactly. Okay, so the things that we need are the mean. We need this value of the mean right here and the standard deviation down here, and also the number of measurements. Those are the pieces of data we need. So I've already copied those down into my whiteboard here. So our mean is 1.52767. Our standard deviation is 0.0013. We have n equals 8 measurements. So our degrees of freedom will be n minus 1 for an average like we have. So our degrees of freedom will be 7. We know we want 95% confidence. So then we can look up the value of t that we're going to need. So going back to my PowerPoint here. So we go to 95% confidence interval, 7 degrees of freedom, 2.365 is the value of student's t. And then we can plug this into the confidence interval formula. So the confidence interval is equal to the mean, 1.52767, plus or minus t. T is 2.365 times s, 0.0013, divided by the square root of 8, because we have 8 measurements. And one thing to keep track of here is that the square root here is for all the measurements, n equals 8, whereas the degrees of freedom will be n minus 1. So something to keep track of here. So let's go ahead and multiply this out. So we've got, let's multiply our fraction on the right, 2.365 times 0.0013 divided by square root of 8, which gives us 0.001. Again, we'll round this to just one significant figure. So our confidence interval is 1.528 plus or minus 0.001. So that means we have 95% confidence. 95% of the time, the true mean for the sample that we measured would lie within the range of 1.527 up to 1.529. To visualize this, what this means, let's look at a figure from your textbook. So this is figure 4-5, and this is illustrating different confidence intervals for a set of random data. So this is a bunch of random data that was generated in sets of 4, and the four values were averaged. And there's all supposed to have, and the way the data was generated, they should have the true mean is 10,000. And so on the top, we're looking at confidence intervals that are at 50% confidence. And we see, these sets of 4 data that we have, so each of these confidence intervals are calculated based on 3 degrees of freedom, 4 measurements, and that value of t based on the standard deviation of the data. And so what we can see is that about 50% of the time, we have these white dots, these white squares indicate that the confidence interval includes the true mean for the actual set of data. And so that's only true about half of the time at a 50% confidence interval. So this interval is smaller, but and it means that the true mean only 50% of the time will lie within that range. In contrast, a 95% confidence interval has a wider range, and 95% of the time, so out of this set of 100 data, we just have a handful of, well, I don't know if this is 100, but it is. We have a handful of measurements where the confidence interval lies out, where it does not include this true mean. So actually, this is a 90% confidence interval. So we see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So about, it's like 89% of the time, we get the range will include the true mean. So it tells us, what's our confidence that what we measure will give us the actual mean of if we were able to measure this set of data, many more times.